Hi friends, in this video we are going to discuss about the previous gate question. Next question, very easy question and very repeated question for any competitive exams. See, in a synchronous machine, hunting is predominantly damped by Generally, in synchronous machine, hunting is mainly due to sudden change of load, sudden change of excitation, sudden change of supply frequency. These are the reasons for hunting. How we can eliminate the hunting? By choosing better synchronizing power, we can eliminate the hunting. By using flywheel also we can eliminate the hunting, because flywheel which opposes sudden changes in speeds. And also very important, damper winding. By using damper winding we can avoid the hunting. Yeah, by using damper winding. For example, this is my synchronous machine, which is salient pole synchronous machine. Where we are placing the damper winding, generally the damper winding placed under pole shoes, nothing but the damper winding placed on the rotor. The extra winding placed on rotor, winding nothing but the copper. So, in which of the following is the correct answer? 1. Mechanical losses in the rotor. No. Due to damper winding, there is no any extra mechanical losses. This is the wrong answer. Iron losses in the rotor. This is the winding. For this winding, there is no reason for iron losses. There is no cause of iron losses. So this is also wrong answer. Copper losses in the stator. Actually, the damper winding placed in the rotor. That's why this is also wrong answer. And next one, copper losses in the rotor. Yeah, of course, this is the correct answer, because the winding placed in the rotor, because of unevenness, the damping torque will produce when the current flows in the winding. Nothing but when current flows in the damper winding, it produces damping torque and also copper losses in the rotor. So, what is the answer? Yeah, this is the copper losses in the rotor predominantly damp out the hunting phenomena. Right, next question. See this one. Here, non-salient pole, synchronous generator having synchronous reactance of 0.8 per unit. What they given? Synchronous reactance they given 0.8 per unit. Supplying 1 per unit power to unity power factor. What is the power? 1.0 per unit. The power factor is unity power factor. Unity power factor load at terminal voltage of 1.1 per unit. My terminal voltage 1.1 per unit. Neglecting the armature resistance, nothing but impedance angle 90 degrees. The angle of the voltage behind the synchronous reactance with respect to angle of terminal voltage. In degrees, they want nothing but they want the angle between EMF comma voltage. They want the angle between EMF and voltage. So first, we have a formula to find EMF. E is equals to V plus IAXS. Yeah, but we don't know IA, right? What is the formula for IA? P is equals to root 3 VL IL cos pi. VL IL cos pi. So for this, IA is equals to per unit values. That's why IA is equals to how much it is? P 1 divided by root 3 and VL and cos pi. If you calculate this value, you can get 0.91. Actually, this is in terms of per unit. That's why no need to take the root 3 value, right? No need to take the root 3 value. Here P is equals to VLIL cos pi. Then IA is equals to 1 divided by 1.11. Then you can get 0.91. Yeah, 0.91 per unit is my IA. 0.91 per unit is my IA. Then substitute here. E is equals to 1.1 at an angle 0 plus 0.91 at an angle 0. Why this is 0? V is the reference. Why this is 0? Unity power factor. Multiplied excess 0.8 at an angle 90 degrees. Why? Because the impedance angle 90 degrees. If you calculate this value, you can get 1.319 at an angle 33.49 degrees. What is the value? This EMF, if you calculate this one, you can get 1.319 at an angle 33.49 degrees. 33.49 degrees. So, what is the answer? E at an angle delta is equals to 1.319 at an angle 33.49 degrees. So, delta, the load angle between E and V, is equals to 33.49 degrees. 33.49 degrees. This is our answer. Just we have to know the IA first. Then after you have to substitute IA here. P is equals to root 3 VL. Sorry, normally for per unit values, VL, IL, cos pi. Then you can get 0.91 per unit. Then we can get EMF at an angle delta. So delta is our answer. Right, next question. Consider a system consisting of synchronous generator working at lagging power factor. What is that? Synchronous generator, lagging power factor. Synchronous motor, overexcited. Synchronous motor, overexcited condition. And directly grid connected induction generator. And next one, induction generator. Consider capacitive VR to be a source. And inductive KVR to be a sink reactive power. Capacitive VR is a source and inductive VR is a sink to the reactive power. Which one of the following is true? They are asking which one of the following is true. Which of the following is a sink? Which of the following is a source? Induction generator, synchronous motor. In the three, which is the source, which is the sink? They are asking like that. They given you options like that. So tell me, which of the following is the sink? Generally, synchronous generator under lagging load, nothing but under overexcited condition, delivers the reactive power and delivers the active power. delivers the reactive power, nothing but delivers the lagging reactive power, delivers the lagging reactive power, delivers the lagging reactive power, not absorbs the lagging reactive power. And next one, synchronous motor overexcited condition, overexcited condition takes the active power motor as well as takes the reactive power which is leading load, which takes the leading reactive power, nothing but which takes the leading reactive power, nothing but which delivers the lagging reactive power. So this is the delivers lagging reactive power. This is also delivers lagging reactive power. Induction generator. Generally, induction generators are observers, reactive power observers. This is the lagging reactive power absorption, or takes the lagging reactive power. Takes the lagging reactive power. This is delivers the lagging reactive power. This is delivers the lagging reactive power. Now tell me which of the following is source, which of the following is sink. The synchronous generators, synchronous motors are the source of the reactive power. Induction generator is the sink of the reactive power. Induction generator is the sink. Synchronous generator and synchronous motors are sources of the reactive powers according to our question. Lagging, which delivers the lagging reactive power. Synchronous motor overexcited condition delivers the lagging reactive power, but induction generator absorbs or takes the lagging reactive power. So these two are the sources and this is the sink, right? Next question. A three-phase 50 Hz salient pole synchronous motor, has per phase synchronous reactance along the d-axis 0.8 per unit and q-axis 0.6 per unit. Resistance neglected. Drawing the full load current. IA is equals to 1 per unit. Power factor 0.8 leading. Terminal voltage 1 per unit. Then find induced EMF for salient pole alternator, for salient pole motor. The induced EMF in per unit. What is the value for salient pole motor? The induced EMF E is equals to V cos delta plus IDXD. Now we have to find out delta. We have to find delta. Actually, for synchronous motor, Xi is equals to 5 plus delta. Phi is equals to cos inverse of 0.8, nothing but 36.6 degrees. Then next, we have to find out psi. Tan psi is equals to V sin phi plus for leading minus for lagging in synchronous motor. IAXQ divided by V cos pi plus RA 0. Now calculate this value V into, what is V? 1 per unit into cos phi 0.8, so sin phi 0.6 plus 1 into XQ 0.6 divided by 1 into cos pi 0.8. If you solve this, you can get psi value the xi value you can get 56.30 degrees. 56.30 degrees. Here, phi is equal to cosinus of 0.8. Its value 36.86 degrees. Then after xi value 56.30 degrees. Now we have to find out delta from this. Tell me delta is equals to xi minus phi. Xi minus phi is the angle around 19.7 degrees. 19.7 degrees. If you calculate this delta, you can get the value. Delta is equals to 19.7 degrees. 19.7 degrees. So I got delta and I know V, I know XD. What about ID? What about ID? In salient pole machine, ID is equals to IA into sine xi. What is IA? IA is 1 sine xi, sine 56.30 degrees. Its value, if you calculate this ID value, you can get 0.831 per unit. 0.831 per unit. Now substitute all the values here. Substitute all the values here. V 1 per unit. Cos delta 19.7 degrees. 19.7 degrees. Plus ID. What is ID? 0.831. 0.831 multiplied by XD. XD 0.8 multiplied by XD 0.8 multiplied by XD 0.8. Yeah, I substituted all the values here. I know V, I calculated delta, I calculated ID, I know the XD. If you calculate this value, then the EMF is equals to 1.606 per unit. 1.606 per unit. 1.606 per unit. This is our EMF per unit. EMF per unit. In salient pole machine, EMF is equals to V cos delta plus ID XD. We know the value. Delta for delta, I calculated xi. Then after I have a formula, xi is equal to 5 plus delta for motor. For motor, 5 plus delta. Then I calculated the value. And delta, I calculated delta. Then after I calculated ID, ID is equals to IA cos xi. ID is equals to IA cos xi. IA cos xi. Then substitute all those values, then we can get the answer. Right, next question. See, this is very important question. The power consumption of an industry 500 kVA. Power consumption of an industry 500 kVA. 500 kVA. 500 kVA. Its power factor 0.8 lagging. 0.8 lagging power factor. Nothing but 36.86 degrees angle. Synchronous motor added to raise the power factor. Synchronous motor added to raise the power factor to the unity. To get the unity power factor from 0.8 to unity. If the motor takes 100 kilowatts, the motor rating they given 100 kilowatts. Then tell me, what is the power factor of the motor? What is the power factor of the motor? Actually, its resultant should be like this. Because unity power factor, its resultant should be like this. there is no any reactive power, then only we can get the unity power factor. Then only we can get the unity power factor. Nothing but the resultant value is like this or like this. This is the 100 plus kW, 100 kilowatts plus the kilowatts of the industry, actual industry. But the reactive power should be zero. This reactive power should be zero. How we can get that zero reactive power? This reactive power should be equals to this reactive power. Q1 should be equals to Q2. Q1 should be equals to Q2, then both gets cancelled out and actually the power should be like this. Now tell me, what is Q1? What is Q1? Tell me, actually we have kVA, I want kVAR. kVAR is equals to kVA into sine phi. We know this is already, right? So tell me, what is the value kVA? How much? kVA is the 500 multiplied with sine phi. If cos phi 0.8, sine phi 0.6, nothing but 300 kVAR. 300 kVAR is the phi 1. When this is 300 kVAR, this also must and should be 300 kVAR. 300 kVAR. Then the power factor is unity. Now I have a kVAR value 300 kVAR motor, kVAR, and kW 100 kilowatts. Now I want the power factor. Generally, for this, for example, this is phi. Tan phi is equals to the power factor angle of the motor. The power factor angle of the motor, tan phi is equals to opposite by adjacent. The reactive power Q2, the reactive power Q1, the reactive power Q2, the Q2 by P2, nothing but 300 by 100. If you calculate this value, the power factor angle of the motor, the phi m is the phi m value is 71.56 degrees. If the reactive power 300, active power 100, then you can get the angle 71.56 degrees. Then tell me, what is the power factor? Power factor is equals to cos phi m. Cos phi m is equals to cos of 71.56 degrees. 71.56 degrees. Then this power factor is 0.316 leading. 0.316 leading. This is the power factor of the motor, 0.316. The power factor of the motor, 0.316, because Q value 300, active power 100. If you calculate this, the angle 71.6, then we can get the cos pi. Cos pi is equals to 0.316. Yeah, this is the answer for this question. Right, next question. See, a three-phase 50 Hz star-connected cylindrical rotor synchronous machine. Star-connected cylindrical rotor synchronous machine running as a motor. The machine is operated from 6.6 kV grid and drop current at unity power factor. Synchronous reactance they given 30 ohms per phase, and the load angle they given 30 degrees. The power delivered to the motor in kilowatts. What is the formula? Generally, power P is equals to 3 into E phase into V phase by XS into sine delta. This is actually our answer. So we have to find out E. We know the V phase value, we know XS, we know delta. Just I want E phase. For that, here the hint is that this is operating at unity power factor. When it is operating at unity power factor, nothing but normal excitation. Normal excitation, nothing but E cos delta is equals to V. E cos delta is exactly equals to V. So E is equals to V, 6.6 kV. V phase value by root 3. By root 3. Vt by cos delta. Vt by cos delta. By cos delta. Cos 30 degrees. So this is, for example, E line, and E phase is equals to 6.6 into 10 cube by root 3 and cos 30 1 by 2. 1 by 2 cos 30 1 by 2. So what is the answer? What is the answer? Cos 30 value. Cos 30 value. How much cos 30 actually? The cos 30 is equals to, this is E phase and again E phase. Right, sir. Next question. See here. A 3-phase 50 Hz star connected cylindrical rotor synchronous machine running as a motor. Operating from 6.6 kV. This is the line voltage. What is the phase voltage? 6.6 into 10 cube by root 3 volts is the phase voltage. And they given unity power factor. Unity power factor, nothing but normal excitation. And they given excess per phase 30 ohms. And they given load angle 30 degrees. Yeah. Now we have to find out the power developed or delivered to the motor in kilowatts. What is the power? We have to calculate that power. Tell me, what is the power formula? Generally, power P is equals to 3 E phase V phase by XS sine delta. I know delta, I know V phase, I know XS, but I don't know E phase. For E phase, they given the small trick, unity power factor. Normal excitation. In normal excitation, E cos delta is equals to Vt. Then E is equals to Vt by cos delta. So tell me, Vt 6.6 into 10 cube by root 3. And cos delta is the 30, cos 30 root 3 by 2. So I got E phase also. Now substitute the value, then you can get the answer. Very simple question. Tell me, P is equals to 3 multiplied by 6.6 into 10 cube divided by 6.6 into 10 cube divided by 3 multiplied by 2. This is E phase. And V phase 6.6 into 10 cube divided by root 3 whole divided by XS multiplied by sine delta multiplied by sine 30 degrees. Yeah, if you solve this one, then you can get the power P is equals to 838.3 kilowatts. 838.3 kilowatts is your answer. Very easy question.